Welcome back. All right, so had a few requests on how to learn how to use a multimeter, and so we're going to dive into that. And I have a few tools and some tools I couldn't find that I really wanted to show in this video, but it's okay. Uh, we'll get through it, and I'll teach you as best I can. I use a multimeter almost every day. I use a multimeter every day. Um, but it's kind of hard to explain in a few-minute video, but we're going to try. And I hope you learned something. If you don't know how to use a multimeter, if you already know how, it's okay. Bear with me, and if you have comments, I've left something out or uh, do it this way, whatever, make a comment and I will respond. So let's get into it. Now I have a few different meters here, and just for demonstration, this is what they call an analog meter. And this meter, it has a needle instead of a digital display, and that's how meters used to be. And you can see here, you have to select what range you want. This is a manual range meter, and I'll show you what that means here in a minute. But basically you have to select what voltage you're expecting or what ohms you're expecting. Actually, the ohms are here. These are volts AC. You have to manually select the range. This is a auto ranging multimeter, but it's also an amp clamp, and I use that a lot. The amp clamp, you can clamp this on your positive battery cable on your vehicle, like if you have a parasitic drain. In other words, something is draining your battery. You don't know what it is, but you know with the vehicle off, everything shut off, you can clamp that on your positive battery cable and see how many amps are being drawn, and basically start pulling fuses until that meter shows little to zero amperage being drawn from your battery. And you'll find your parasitic draw, with each fuse you pull, you'll notice if there's a difference or not. And when you pull a fuse that makes a big difference, that's where your parasitic draw is. So this is my favorite meter. It's not it looks new, but this model is an old model. I use this in school, and I use this uh, not the same meter, but I use the same model of meter, the exact same meter at work. My work meter is all dirty and beat up, greasy and grimy. But this is my home meter. Santa Claus brought this, and these are fairly expensive. This meter here does the exact same thing, and it's got the amp clamp, and you can get this at Harbor Freight for maybe $60, $70, where this meter is, depending on where you buy it, $300 to $500. That's kind of an expensive meter. So the others are just testers. This is a tester, just a voltage tester. This is my dad's. He's passed away, but I have his voltage tester now. He was an electrician, and he called these a Wiggy, but Wiggy is the brand. This is actually an Ideal brand tester, uh, but he always called them Wiggies, and that's something I'll never forget, learning from my dad. And this is a voltage tester, and you can just plug this straight into a receptacle, you see it's got a plug on one end, and it tells you if your plug is wired right, and it's even got a little uh, description of the lights to tell you what's going on with your outlet. So we'll try these voltage testers out real quick. This voltage tester, we'll plug this in and we'll see how many lights light up and which ones. So you push it in the receptacle, you got 1, 2, 3 lights, but only the middle and the right light is lit up. So we'll look and see what that means. And if you can see that, it's the bottom one, and it says correct. That this receptacle is wired correctly. In other words, you don't have the neutral and the ground reverse, or the hot and the neutral, or whatnot. All three, because when you're talking about 110, there's three. You have the hot, neutral, and ground, and you can wire those differently in a receptacle. They can be incorrect, and you might still run a device or an appliance or whatnot, but it might act funny, it might act suspicious, or it might not work at all, and it could be because you have your plug wired differently. This little button here will trip this GFI ground fault interrupter. So basically that's a circuit breaker built in to the outlet, and we can trip it to see if the ground fault still works correctly, and then reset it. But I don't want to do that because, as you can tell, I've got other things connected. But look here, we can take this cord off this extension cord reel, which is also connected. We can plug that in, and we've got our two lights that say correct. That rooster, he's so annoying. We've got our other voltage tester, as my dad would call a wiggy. And I don't know if you can hear that when I shake it, but when there's voltage running through here, you'll hear that sound, and there'll be a light, and I'm not sure if you're going to be able to see it or not. So what we'll do is we'll stick this in here, and we're hoping to see 120 volts. If I can get these leads in, they're kind of worn out. All right, so watch when I probe the outlet, trying to get a good angle here. When I probe the outlet, you'll be able to see an orange bar drop down to the 120 volt AC. 120 volts. And there's a red test light in there, or well, orange, amber. And that is that voltage tester. Before we dive into a meter, I want to show you that there are different types of ends for your leads. So you have your positive and negative probes, if you will. Some people call them both probes. Some people say that's the lead, this is the probe, but we all know what you're talking about. But these ends come off. They just pull off, and if they're tight, it's okay. They're supposed to be. And you can put these other ends on them. You can put this end on here, And this will, grab a wire so you don't have to hold your lead, and I'll demonstrate that. Got your positive and negative. This well, that's the wrong end. This one is called a back probe. Take this little tip off, little silicone tip. It's really sharp. And you can kind of stab into electrical connectors and back probe those to get voltage or ohms or whatnot. You can stab heavy gauge wire with these. They're used for lots of different things. And there's one for the positive, and it doesn't matter what color they are. I mean, sometimes you find them green, blue, purple, whatever. It doesn't matter as long as you know which end you got plugged into which lead. This is a wire piercing lead, and basically it's kind of almost like a syringe or something. You open it and you stick your wire in that little groove right there. I know my fingers are dirty. I've been turning wrenches all day. But yeah, it pierces your wire when you don't have any good place to probe or back probe. And that's kind of a quick run through on those. The first thing we'll do is we'll test the fuse. So take like just a regular blade fuse. This is just a normal 10 amp. I think that's focused. A 10 amp blade fuse like you would have in most cars. I'm an old guy. I might say most automobiles. So if you wanted to check it and see if it was good, you would set your volt-ohm meter, multimeter, whatever you might want to call it, to ohms. This is why I like auto ranging. You don't have to select what kind of ohms you're looking for, but I'm going to tell you what we're looking for. We're looking for like 0.2, 0.34 ohms, like point. So you'll see, maybe you can see that better with the backlight. So this, our ohms emblem, that's what we want to put it on. And we'll even make it audible so you can hear. These chickens are driving me crazy. Okay, so right now it says OL. That means when you're on ohms especially, it means open loop. So electrical circuits, it is what it is. It's a circuit. It runs in a loop. So if the loop is open, that means there's a break in it somewhere. There's not continuity. There's not a connection. It's open. But if you connect it, if you connect the loop, so like we got 0.3 ohms just touching our leads, which means my leads are probably getting worn out, even though they look brand new. So we'll test this fuse. We'll put a probe on each spade of the fuse and see what our meter reads. And it should be, there we are, 0.3, 0.2. So that means there's only 0.3 ohms in this fuse, which means it's very, very low resistance. Very low resistance, which means it's good. It's not burnt. So in these types of fuses, typically you can look in here and see that kind of horseshoe shape, and a lot of times it'll be blackened, or you can actually see a break, or it might even be gone until the fuse is bad. But there's some rare occasions where it's not blackened, you can't see a break, and the fuse looks fine and it reads correctly. But as soon as you apply power to that circuit, you lose power, because electricity creates heat. And as that break heats up, the metal, inside there'll be a gap. Gets hot, creates a gap. A gap big enough where the electricity cannot jump across. It can't arc. And if it can arc, it does funny things. But sometimes even a multimeter can fool you when testing a fuse. But 98% of the time, your multimeter is going to be spot on with your fuse. So now we'll take and we'll ohm out this wire. But when we do, we're going to change our leads just to demonstrate how they work. So we'll use this end that's kind of like an alligator clip, and we'll put it on this bare spot. But you're inside of a car, or in my case, a piece of equipment, and you can't get to this end. It's just not possible to reach it. But you can get close with this, and you can pierce the wire. Make sure I'm plugged in all the way there. We're doing some Morse code kind of stuff. Make sure we're pierced all the way. Yeah, we're still doing some magic jumping. This should be a known good wire. So we're reading more resistance than that fuse. 30 to 40 ohms. Right there, we're reading 4 to 5. So this wire might actually have a break in it. We're down to an ohm. I may have used a bad wire for this demonstration, because it shouldn't have read that high. That's normal. So I wouldn't be surprised if there is a break through here, and that might be why I had this thing laying around. So that demonstration tells you a lot that you can read with a meter. We found a break unexpectedly. It's not a complete break, it's just a weak spot in the wire. We already found that with a meter. So now we have a resistor. You can see, hopefully, these things are really hard to see. I hope you can see that. You can see the rings around it. This magnifying glass isn't the best. But I use one of these devices to hold tiny things like that. And this is a 680 ohm resistor. And we can check the ohms, or the ohmage, as I like to call it. We'll just clamp one of these dudes on here, and one of these dudes on the other end. Let's see where our resistance is. So that is 673 ohms. And one thing that will signify that, so like you have a K right there, K ohms, that's reading in thousands of ohms, but you have your decimal point. So 0.673 is the same as 673 ohms. So for 680 ohm resistor, that is really spot on. That's, you have a little bit of leeway in your leads, you have a little bit, and you'll never find a resistor that reads what it says it's going to read, but it's going to be close. So we'll move from that to, now we have a diode. So a diode lets electricity flow in one direction. It only flows in one direction. It can't flow in the opposite direction. And I will make an example. I don't know if you can see this, but there's a silver line around that resistor. I hope you can see that. They're tiny. They're very tiny. And I can't see it without the magnifying glass. So we'll hook our leads up. And when you're checking ohms, there's a slight voltage, like millivolts, milliamps, that travels from positive to negative. So when you hook the two together, uh, the meter reads how much resistance is between these two leads. So we'll measure the resistance of this diode. Well, knock my holder over. So here we have, oh well, all right. So we'll reverse it. And here we have 282 ohms. That means that electricity flows from this direction to this direction, but it will not flow from this direction to this direction. Since we switched our leads, we know that that silver line is the negative side. Those are the basics of using a meter, and I always prefer, you don't have to buy this expensive one. You can buy a cheap Harbor Freight one for most home use. And I recommend not using a meter for amperage unless you know for a fact, uh, like this one's rated 10 amp max. And it's got a fuse inside, but it doesn't guarantee. You can burn up one of these $500 meters if you rely on that fuse to blow. And if you use your meter regularly, you're going to have a fuse on hand, and you got to take it apart. You got to take the cover off of it and screws out of it, and it's time. It's not really a pain in the butt, but it is if you're in a hurry and you really need to use your meter. So I recommend against that. Don't use it for amperage. Use the amp clamp, like I was telling you about. You want to be able to clamp things, especially like checking parasitic draw, or if you want to see if your alternator is putting out amperage on your car, use an amp clamp. Uh, Lots of many different uses. And without making this a 2 week long video, it's hard to go into it all. But don't be afraid of using a multimeter, because you can do a lot of things around the house with it. They're very handy, and if you're a homeowner, get one. If you're not a homeowner but you own a car, get one. Get a meter, because you can do so many things, and you can find some cheap ones out there that are fine for what you're going to use them for. And I appreciate you watching my video. And if there are any videos you would like to see me create, leave it in the comments. Let me know, because I don't mind sort of leaning that away. You know, whatever the viewers want, I'll try to give them whatever you're trying to learn, and I'll try to show it to you. Thanks for watching.